Enthalpy of reaction, delta H reaction. So this question is asking you to use the standard enthalpies of formation in the table below to answer the questions. So when you're looking at the questions, if you can see, you're given substances, molecules. You're not given bonds, so don't get confused about thinking it's a bonds breaking type of question. It's not. You've got your substances already, so you're going to be using them. Question A is calculate the enthalpy change for the following reaction. You're going to be using the table and the reaction to calculate delta H. So think of the formula that you're going to be using. We've got delta H reaction is going to be equal to the sum all of the delta H formation of the products. That's these over here, the products, and you're going to be subtracting the sum of the enthalpy of formation of your reactants. Now what many people do is to write the formula out perfectly and then write the numbers as they are in the equation, which is wrong. So make sure you write now what are your products and what are your reactants. So we've got over here as our products, we've got CO2 and we've got 2H2O. And from that you're going to subtract your reactants, and your reactants CH4 and 2O2. Great, so it's all set up. Now you can start doing your substitution. So using the numbers at the top, CO2 is minus 394. You're then going to be looking at water. We've got 2 of them, so make sure you do 2 multiplied by water, which is minus 286. And then you're going to be subtracting methane, which is minus 75. And from that, you've got 2 times 0, which of course is 0. So looking at these numbers, you've got minus 394. Now you've got your minus here, so 2 times 286 is going to be minus 572. Then don't forget that your minus with a minus makes a plus, so plus 75. And you should find out that your total answer is minus 891 kilojoules per mole. And where did we get this unit from? Well, looking up here, we've got kilojoules per mole, so that's how you're going to end up with that as your unit. So there we are, answer for part A. Then we can go ahead and look at question B. Calculate the change in enthalpy for the above reaction when 32.1 grams of methane is burnt. So you're looking at enthalpy, methane, and you're starting off with a mass. So you've got your equation. Your equation is here. And from this equation, you've got your link that 1 methane, CH4, has a delta H of minus 891 kilojoules per mole. So you can be thinking, if you know that 1 mole of methane has a delta H of that, then what's a different amount of methane going to give you as an enthalpy? So you should be thinking now, you can't keep it as a gram, as a mass. You need to change it to moles, and then you'll be able to use the above ratio to work out your answer. So you've got a mass of methane. What you're going to be doing, first of all, is changing it to a mole of methane. You know the formula is moles is mass over molar mass? Well, your mass is given to you in the question, 32.1. The molar mass, you're going to have to calculate. So your molar mass, CH4, you're going to have to work out your C, and you've got 1 C, and from your periodic table, carbon is 12.01. You've got hydrogen, you can see there are 4 of them. Hydrogen is 1.008, which is 4.032. So when you add them up together, you're going to end up with 16.042 grams per mole. Okay, you're using everything to 3 significant figures because that's what you've got in your question. So we'll get rid of the 4 and the 2. Okay, so we've got 16.0 grams per mole. And you should find out that your answer for this, basically 2 moles. Okay, so that's what you've got for your moles of methane. Now, as I said, we've got that above link, so we can see that when you've got 1 CH4, your delta H is minus 891 kilojoules per mole. So this time you've got 2.00 moles CH4. So with some cross multiplication, you should be able to see that your enthalpy of reaction when you've got 2 moles of CH4 is going to be minus 1,782 kilojoules. Now it's not per mole because you've got more than 1 mole. So this is going to be your answer. Hope that helps.